find your 2.4 fractions and decimals notes. We're going to go through those together today and get those all written down. Here is our standard. I can read, write, represent, identify, and compare rational numbers. And our rational numbers today are going to be fractions and decimals. Our goal is I can convert between fractions and decimals. So can you go from a fraction to a decimal? Can you go from a decimal to a fraction? This is not a new skill if you were here with us last year. You have done this before, but now we're just going to take it to that 7th grade level, and I'll tell you when we do. First of all, let's do some review. When you see a decimal point, what word do you say? And. Like, whenever I'm dealing with decimals, money is a really helpful thing for my brain. So I would read this as $5.10. So remember that decimal point, we say the word and. What is it called when a zero is used or removed and it does not change the value? Annexing a zero, or an annexed zero is another way to say that. For example, if I have this picture here, what fraction of the picture is colored in red? You would say 1/10. Well, as a decimal, there's 1/10. But what if I took that picture and I cut it up into 100 pieces and still had the same amount colored in? Now I would say I have 10 hundredths. And 10 hundredths is the same value as 1/10. They're equivalent. This zero that I added on the back here didn't bump any of the other digits out of their room in our place value system. This is what we call an annex zero. I can remove it, I can add it, and it doesn't change the value. I could take those exact same pictures and I could cut it up into 1,000 pieces and I could color in 100 of them, 100 thousandths, and it would represent the same value as 10 hundredths and 1/10. These two zeros are annexed zeros. If I remove them, it doesn't take any of these digits and bump them out of the room that they're in our place value system. So annex zeros are really important to be mindful of when you're working with decimals. Let's dive into our notes. Find that first chunk. We're going to convert a decimal to a fraction. So I have a place value chart up, and I'm going to reference that every once in a while just to get our minds thinking in fraction and decimal mode again. So how do we do that? How do we change a decimal to a fraction? How we read it is how we write it. So here's your first example. Write that down. If I plug that into my place value chart here, how would I read it? Go to the digit that is not a zero. It is 6, and then the room that it's in is hundredths. So I would read it as 6 hundredths. That's how we write it as a fraction. And of course, we want to look to see if we can simplify. And we definitely can. We can divide them both by 2 to get 3/50ths. So the fraction that's equivalent to this decimal is 3/50ths in its simplest form. Here's example 2. Write it down. How you read it is how you write it. This 8 is in the tenths room, so you read it as 8/10. That's how we write it. Can you simplify 8/10? You bet you can. 4/5. So the fraction 4/5 is equivalent to this decimal 8/10. Here's number 3. Write it down. If I take this decimal and I plug it into my place value system, this 5 would be in the thousandths room, right? 225. So I would read it as 225 thousandths. That's how I write it. Now I can definitely simplify that, and it might take you a couple times to simplify it because maybe you see right away that you can divide them both by 5. I see that I can divide them both by 25, and that's going to give me 9/40ths, which is equivalent to my decimal right over here. Last example in this first chunk. Write it down. Now this 0 right behind the 7, if I take that out, does it bump any of the digits to its left out of its room or their rooms? No, this is an example of an annex zero. So I can take that off and I would have 0, 7, right? Which I would then read as 7 hundredths. So 70 thousandths is the same as 7 hundredths. Thinking about that annex zero there. So I would write it as 7 hundredths. You could write it as 70 thousandths, but you're dealing with higher numbers there. Sometimes it's easier to deal with lower numbers. So can I simplify 7 hundredths? Nope, it is in its simplest form. So how do we change a decimal to a fraction? How we read it is how we write it. Same works for decimals to mixed numbers. Go to the second chunk in your notes, write this decimal down. I would read it as 16 and 1/10. That's how I write it as a mixed number, 16 and 1/10. I'm going to ask myself if I can simplify the fraction part here, and I can't. It is in its most simplest form. Write down example 2. This 5 is in the ones place. This 8 is in the hundredths place. So I would read this as 5 and 8 hundredths. That's how I write it as a fraction. Looking at the fraction part, can I simplify it? Yes, I can. I can divide both by 4 to get 5 and 2/25. Let's look at the last example in this second chunk in our notes. 24 and go to this last digit. What room is it in? Tenths, hundredths, thousandths. I see the number 22 in there, so I'm going to read this as 22 thousandths. That's how I write it. Can I simplify the fraction part? You bet I can. I can divide the numerator and denominator by 2 to get 24 and 11/500ths. So remember, when we're changing a decimal to a fraction, these are all terminating decimals, right? They stop. They don't go on forever. How you read it is how you write it. Let's go to the third chunk in our notes. Now we're going to go from a fraction to a decimal, so the other way. Remember, a fraction is really a division problem. So we're going to go numerator and divide it by denominator. So if you don't have a calculator handy, please go get one. First, pause the video. If you do, let's keep working. So we're going to go numerator divided by denominator. So I'm going to go 5 and divide it by 8. That is going to take this division problem and show it as a decimal. So 625 thousandths, tenths, hundredths, thousandths, 625. And then my last digit is in the thousandths room. Write down example 2, 7 and 1/5. So I'm going to only focus on the fraction part to change to a decimal. My 7 wholes stays the same. So I'm going to go 1 and divide it by 5 to get 2/10. So this equivalent decimal would be 7 and 2/10. So how do we change a fraction to a decimal? We go numerator divided by denominator because a fraction is really a division problem. Go to the next chunk in your notes. We have 2 real-world problems to look at. I'm going to do the first one with you. The second one you're going to do on your own and then check your work with mine. A construction worker wants to drill a hole with a diameter that is no more than 6/10 of an inch. Can she use a 5/8 inch drill bit? We are trying to figure out if she can use that drill bit. So it's either going to be yes, she can, or no, she cannot. So my sentence is blank, she blank, use the 5/8 inch drill bit. Now, if I go line by line, I normally look for a key operation word, but here it's a comparison phrase, no more than. So she doesn't want the hole to be bigger than 6/10 of an inch. So can this drill bit keep the diameter within 6/10 of an inch? Well, we need to compare this fraction to this decimal. And the easiest way to compare is to put them both in decimal form. So first of all, the numbers I need to work with are the 6/10 of an inch and the 5/8 inch drill bit. So I'm going to take the 5/8 and I'm going to convert that to an equivalent decimal. I'm going to go numerator divided by denominator, and there's my equivalent decimal. So 625 thousandths. Now, my decimal that I'm given in the problem only goes out to the tenths room, but I can annex 2 zeros to make it go out to the thousandths room. And now I can very easily compare. These are both 0, these are both 6, this is a 2, this is a 0. 2 has more of a value, so the drill bit is too big for what she's looking for, right? The drill bit gives you 625 thousandths. She's looking for 600 thousandths or 6/10 of an inch. So no, she cannot use the 5/8 inch drill bit. Go ahead and pause the video, work on number 2, come back and check your answer with mine. Who scored higher on the test? You scored higher on the test. When you turn your ratio, your fraction, into a decimal, 35/40 is equivalent to 875 thousandths. And your friend had 800 thousandths, or 8/10. Your score is higher. This decimal has a higher value than 8/10. So you scored higher on the test. Congratulations. Let's go to the next chunk in your notes. Still working with fractions and changing them to decimals, make sure you have that calculator handy still. This time, our fractions are going to give us decimals that repeat. And when we have repeating decimals, to show the digits that repeat or the digit that repeats, we got to make sure we use the notation bar. Let's change 5/9 to a decimal. 5 divided by 9. 0.55555. The calculator rounds up the digit there that would be the last one on the screen because the screen on the calculator doesn't go on for forever. So this digit 5 repeats. How do we show that? We put a notation bar over that digit. Go ahead and change 4/9 to a decimal. 4 divided by 9. 0.44444. This 4 is going to repeat forever. So to show that 4/10 repeats forever, we put a notation bar over the digit. 53/99. Let's change that to a decimal. 53 divided by 99. 0.535353. It rounded up that 3 to a 4, right? The calculator screen can't go on for forever, so sometimes it'll round up that last digit if it's appropriate to. Since 5-3, or the digit 5 and 3 repeat, we want to make sure that the notation bar goes over both of those digits. Here's our final example, 178/999. It's kind of a difficult fraction to say. 178 divided by 999. There's my decimal, 0.178178. It took the 7 that was here and it rounded up to an 8, but the 1, 7, and an 8 repeats forever. So I want to make sure that my notation bar goes over all 3 of those digits there. Do you notice a pattern here? Well, first of all, you might say, Miss Kluver, each one of these fractions has a 9 in the denominator. You're right. That's part of the pattern. Here it has the numerator number is what's repeating. The numerator number is what's repeating. The numerator numbers are what are repeating. Same thing over here. Here is the pattern. The denominators all have 9. And there's the same number of 9s that there are repeating digits. So for example, the 5 repeats, there's 1 9. The 4 repeats, that's 1 digit that's repeating. My denominator's a 9. There's 2 digits that are repeating. My denominator has 2 9s in it. There's 3 digits that are repeating. My denominator has 3 9s in it. So that is the repeating pattern. Go ahead and make sure you write that down. Off to the left in your notes, underneath the question that says, what is the pattern we see when there are repeating decimals? Now, let's use this to go from a decimal to a fraction again. What does it look like when we have a repeating decimal? Can we use how you read it is how you write it? Not necessarily. So we're going to use that repeating pattern. Here I see that I have 1 digit that repeats. Go ahead and write example 1 down, 3/10 repeating. I have 1 digit that repeats. That 3 is going to be my numerator. And since it's only 1 digit that repeats, that means I have 1 9 in my denominator. Now you got to ask yourself, can I simplify this fraction? Yes, I can. I can divide both the numerator and denominator by 3 to get 1/3. Let's look at number 2. Write example 2 down. We have 8/10 repeating. I have 1 digit that repeats, so that means I'm going to have 1 9 in my denominator, and my numerator is going to be the digit that repeats, the 8. So 8 9s. Can I simplify 8 9s? Nope. It is in its most simplest form. Write down example 3, 74/100 repeating. Now I see I have 2 digits that continuously repeat forever and ever and ever. So that means I'm going to have 2 9s in my denominator. And my numerator is just going to be the repeating digits. So 74/99. Write down example 4, 16/100 repeating. Again, I see that I have 2 digits that are repeating. That means I'm going to have 2 9s in my denominator. And my numerator is going to represent the repeating digits. So 16/99. We have 2 more examples to do with converting a decimal to a fraction where we're dealing with a repeating decimal. Example 5, 225 thousandths repeating. I can see now that I have 3 digits that repeat. That means my denominator is going to have 3 9s in it, and my numerator is just going to represent the repeating digits, 225/999. Kind of a challenging fraction to look at, right? Can I simplify that? I can. Think about your divisibility rules. I always check for 3. I always check for 9. If I add up the digits and they create a multiple of 3, if I'm thinking about 9, if they create a multiple of 9 after I add them up, they're divisible by 9. So if I go 5 plus 2, that's 7, plus 2, that's 9. 9 plus 9 plus 9, that's 27. I know I can divide both the numerator and the denominator by 9. So if I do that, I'm going to get 25/111ths. And here is the simplified fraction for this repeating decimal. Last example, 7th graders, we have 28 hundredths repeating. So we have 3 digits that repeat, 0, 2, and 8. That means I'm going to have 3 nines in my denominator. But notice how I said that? I said 28 hundredths. So my numerator is just going to be the 28. Why, Mrs. Kluber? Because if you put a 0 in front of the 28 here, you would still read it as 28. It would become an Annex Zero in front of the 28. I don't need it there. So it's just 28 999ths. Now, how in the world does this work? How can we just use this repeating decimal pattern of the denominators are going to be 9, and then your numerators are just the digits that repeat? How can we use that? Well, I'm going to give you a quick inside look at how that works. You don't need to write this down in your notes at all. So here I have a decimal, and we know that it's a repeating decimal because of the notation bar. This one is going to repeat on forever and ever and ever. So it could look like this if I wrote it out. 0.11111111. Let's call this x. X equals this value. Now, if I take and I multiply this by 10, tens are really nice. Our place value system is based off tens. Multiplying by powers of 10, dividing by powers of 10 are super easy. It just requires a movement of the decimal either to the right or to the left. When I'm multiplying by a power of 10, I move it to the right, however many powers. Here, I just want to multiply it by 10, so 10 to the first power. This would give me 1.111111. That's all still going to repeat. And if I took this and I multiply it by 10, then 10 times x would give me 10x. Now what I'm going to do is I'm going to subtract these two values from each other. If I do that, here I'm left with 9x, right? 10x, take away an x, I'm left with 9x, equals, if I work on subtracting here, 1 take away 0 is 1, and then 1 take away 1. Well, all of these cancel, don't they? And now I have 9x equals 1. This is a one-step equation. I know what will undo this multiplication of 9 times x. If I divide by 9, we did that last year if you were with us. Here I'm left with 1x, which I can write as x equals 19. I don't expect you to be able to do this on a sheet of paper or memorize this. I just wanted to show you the math behind our pattern that we put in our notes. All right, that brings us to the end of our lesson on fractions and decimals. So how do we change a decimal to a fraction? When it's a terminating decimal, we go, how you read it is how you write it. When it's a repeating decimal, we're going to use our pattern that we wrote down in our notes. How do we change a fraction to a decimal? Well, a fraction is really a division problem. So we go numerator divided by denominator.